So first is, we'll start with recrystallization. What is recrystallization? You try to purify a solute using a solvent and purify it, where your impurities go inside the solvent and you get your pure compound. You get your pure compound. Okay? So selection of solvent is very much important. Selection of solvent is very much important whenever you make a preparation. So it should not be fully soluble. It should not be fully soluble. If it is fully soluble, then the compound does not come out of your solvent, your solute, which you have added. Sample which you have do not come out of your solvent. So you have to prepare a super saturated solution, not a saturated. Even in a saturated, the compound will not come out. So you have to prepare what? A super saturated. You have to prepare a super saturated solution. So what is the super saturated? So in minimum solvent, maximum compound at elevated temperature. You try to put more sample inside your solvent with where the compound gets solubilized in lesser volume of solid, so that once you cool it, the compound comes out. So this is known as recrystallization process. So there are steps involved in this thing. First is primary. You take your compound, you dissolve it in the solvent. The solvent should be not fully soluble. It should be partially soluble. Supply heat to it and you solubilize. So you prepare a super saturated rather than a saturated. So there is something called as primary filtration. That is the first filtration, where you remove insoluble impurities. So in the first preparation, when you solubilize your compound in the solvent, when you do the filtration, you try to separate the insoluble impurities. Separate what? Insoluble impurities. So that's what is the first filtration. So when you solubilize the compound, you see the particles which are not soluble in the solvent will be separated out. That's your first filtration. So you do the filtration. The insoluble impurities will be in the funnel and you get a clear solution here. So in this you contain the compound and soluble impurities. You contain a compound as well as your soluble impurities. So once you have prepared a super saturated solution, as you cool, your compound starts coming out and your soluble impurities will be within your solvent. The soluble impurities will be within your solvent. And you do the secondary filtration. Where your products comes out over here and it cools. Super saturated, when you cool it, the compounds come out. And when you do the secondary filtration, the required product will be over here in the funnel and the impurities, soluble impurities will be in the filtrate, will be in your filtrate. This is how we do the purification. This is known as primary first crop, which contains 99.9% pure compound. Still there will be some compound that might have gone into the secondary recrystallization, that is known as second crop till you get a good yield. Continuously you can do the recrystallization to improve your yields. But the first one is the purest one and it is known as what? First crop. It is known as what? First crop. Got it? Now this was recrystallization. Now we will go for distillation. What is distillation? You might have studied in engineering, where you try to purify your liquid samples. So you got soluble liquids which you want immiscible. Immiscible liquids can be separated using a filtration, using a separating funnel. But soluble liquids, the two liquids are miscible, you cannot separate it. So it can be separated using distillation. Where you separate your liquid samples. Where you separate what? You separate your liquid samples by using the distillation apparatus. So what does the distillation apparatus? It contains a RBF, it contains a T band, Y band, where there is a thermometer pocket, where you can measure the temperature. The thermometer should be over here so that it measures the vapor pressure, vapor temperature. And there is a condenser over here, there is a source of heating over here, and there is a collector over here. There is a collector over here. So when you heat it, your solvent vaporizes, it forms into your paper, and that temperature is monitored, and that's your boiling point of your sample compound. So according to the difference in boiling point, whichever is of the lower boiling point will come out. So what happens is there are two mixtures. One is low melting boiling point, and one is high. So high melting point will give away the heat to the low, and it evaporates and it gets condensed. There is a water supply over here. This will condense over here, and the droplets will be collected in your this. This is the normal distillation. This is known as simple distillation. So this is normal. But when you see this can be seen when the boiling point difference is above 15 degrees Celsius. Above 15 degrees Celsius, if there is a difference, then you can go for your normal distillation. Then you go for what? Normal distillation. When you got boiling point difference that is around 3 to 4 or 5 degrees. Around 5 degrees difference between the two solvents or the samples. Then we have to go for what? Fractional distillation. We should go for what? Fractional distillation. We go for the fraction. What is that? There is an additional fractionating part. There is an additional. This contains different grooves. So that what happens? When you heat it, the high boiling point solvent will go up, and it will give the heat to the low boiling. So low boiling will further go up. So heat keeps on dissipating, and this gets collected over here. So low boiling point will be coming out first, followed by that continuous process, your second solvent. As the height is there, only there is multiple steps going on. So only the low boiling point solvent will come first, followed by your high boiling point. So this is how you separate fractional distillation is used when the boiling point difference is very less, between around 5 to 6 degrees. When there is a difference between the two solvents, then you use what? Fractionating column or fractional distillation. Got this? Now comes the use of vacuum. Why do you use vacuum? You know you can heat it up to 200, maximum you can heat it up till 200 degrees. So above that, it is difficult to heat it. There might be blast also. So what we do? We apply vacuum over here. There is a collector tube. There is a joint for your vacuum. So that when you apply vacuum, the solvent boils at lower temperature. What does it do? The solvent boils at lower temperature. That's how you can distill out high boiling once you are using your vacuum. So vacuum reduces your melting to the boiling point, and you can separate your compound. This is how you can do. This is known as fractional steam distillation. You might have studied it in engineering. What is that? There is a source of steam which is purged into your sample, which contains volatile oils. So volatile oils are separated using, because if you do directly, there is a possibility of char. So what you do? You purge the steam inside it. The steam will remove the volatile oils, and that can be collected in your collector. Okay, this is how you separate. So steam distillation is used for separation of your volatile oil. That is application. It also can be used for determination of your RL value, Polanski's value. So they are low volatile, soluble and insoluble fats and oils can be separated during this steam distillation process. Got it? So this is an introduction of your distillation, crystallization. If the examiner asks, you should be able to know the concept and tell the. Now let's go for the first preparation. So what is the first preparation? What is the first preparation? Is the preparation of phenyl benzoate. It's a preparation of phenyl benzoate from phenol and benzoyl chloride using sodium hydroxide. So it's an example of acylation reaction. It's an example of acylation. You put R, see the introduction of R, C double bond O group. This is known as acyl group. This is known as what? Acyl group. So what type of reaction is preparation of phenyl benzoate? The basic reaction is your acylation. But what you are trying to introduce, you are trying to benzoyl group. So it can also be known as benzoylation reaction. And what is the end product that is formed? Ester. So that is also known as an esterification reaction. So it's an esterification reaction. So this acylation, why it is acyl? RC double bond O group introduction to the phenol. That's why it is known as acylation reaction. Why it is called benzylation? Because benzyl group is C6H5. C double bond O group is introduced to your phenol. That's why it is known as benzylation. And why it is called esterification? Because you get an ester that is formed. You get an ester that is formed. That's why you know as esterification. So what is the mechanism? First is you take, see the mechanism. You take your phenol. You take your phenol. You treat it with sodium hydroxide. The moment you treat it with sodium hydroxide, that's the first step. You treat it with sodium hydroxide, it forms what? Sodium phenoxide. So sodium phenoxide acts as a nucleophile. Sodium phenoxide and your phenoxide acts as a nucleophile and attacks on the carbon of your benzoyl chloride. So this attacks over here, the chlorine is a good leaving group, this is lost, and you get your corresponding phenyl. This is phenyl, O, C double bond O, phenyl. Phenyl benzoate. So why did you? So you get your phenyl benzoate. You get your phenyl benzoate. Okay? This is your first reaction. So what type of reaction it is? Everybody make a note of it. What type of reaction it is? It's an acylation, esterification, or an first reaction is what? Basic reaction is acylation, benzylation because benzyl group is added, and ester because the end product, the functional group that is formed is ester. That's why it is known as esterification. Okay? Got this thing? The first reaction. Everybody understood? So it's an acylation, esterification. And what is the first step? Generation of your sodium phenoxide. Okay? Instead of your sodium and phenol introduction, if you have added your benzyl chloride, instead of your ester, you have got an acid because benzyl chloride will react with NaOH to give your sodium benzyl. That's why the first addition is of phenol and sodium atom. To that solution you add benzyl chloride. Remember this thing, the POC of addition. Got it? Now let's go for the second one. Let's go for the second one. Let's go for the second one. Okay? What's the second reaction? What's the second reaction? It's preparation of parabromo acetanilide from acetone. So what is acetanilide? Your aniline, which contains an acetate group. This is acetanilide. Why do you use this acetanilide? Not aniline. With acetanilide, it is a moderately activated. It's a moderate activator. That's why it is para-galactic. It is basically a para-galactic. Moreover, because of the strict hindrance, the auto effect substitution does not take it. So the major product will be your para. Instead of acetanilide, if you have taken aniline, instead of acetanilide, if you have taken an aniline, you would have got the tribromo derivative because they are ortho-para. They are strongly activated. That's why you would have got an ortho-para substituted product. Understood? So that's the reason why you take acetanilide, so that it is only para-galactic and you get the para-bromo acid. Okay? So sometimes the examiner will ask, how will you prepare parabromo aniline? How will you prepare parabromo? You know, aniline if you treat with bromine you get tribromine. So that's the reason why we convert your aniline into acid anilide. That acid anilide will do the bromination, then followed by your hydrolysis to give you your para-bromo. Okay. This is how we can prepare para-bromo. What is the example of this? It's an electrophilic aromatic substitution reaction. It's an example of what? Electrophilic aromatic substitution reaction. It's an example of what? Electrophilic aromatic substitution. So if they ask you an example for electrophilic aromatic substitution with an activator, we can activate it. Then you should know which reaction you have to answer in the viva or as in the synopsis. You should know what to write, which reaction. If they ask given an example for acetylation reaction, you should know which reaction you have to write. Okay? If they don't ask you directly. Give an example for acetylation reaction is you write preparation phenyl benzene. Did you get the second? Second is over. Now let's go for the third. So what is the third reaction? That is preparation of what? Preparation of benzoic acid from benzoyl chloride using aqueous sodium carbonate. Using aqueous sodium, so it's aqueous oxidation. Alkaline oxidation using KMNO4 potential permanganate. It is your alkaline oxidation of your benzyl chloride to your acid using KMNO4. KMNO4 is an oxidizing agent. Let's make a note. KMNO4 is an oxidizing agent. Make a note everybody. KMNO4 is an oxidizing agent. It converts your, what is the first step that is occurring? You have your benzyl chloride. Yes, you treat it with, when you take it in aqueous solution, your benzyl chloride is converted to your benzyl alcohol. This, when you treat it with alkaline KMNO4, it undergoes oxidation to give you your sodium salt of benzoic acid, which on further neutralization with HCl, you get your benzoic acid. You get your benzoic acid. So what happens? Benzyl chloride gets converted into benzyl alcohol, which gets oxidized in the presence of alkaline sodium carbonate to give you your sodium salt of benzoic acid, which on neutralization with HCl, you get your what? Your benzoic acid. So it's an example of third reaction. This reaction is an example of oxidation. Right? Oxidation, and oxidizing agent is KMNO4. Oxidizing agent is KMNO4. Potassium permanganate. Potassium permanganate. What's the next reaction? What's the next reaction? Nitrobenzene. What is nitrobenzene? You take benzene, you take it with concentrated H2O3 and H2SO4. So which type of reaction is this? Which type of reaction is this? It's an example of electrophilic aromatic substitution reaction. It's an example nitration. It's an example of nitration, that is electrophilic aromatic substitution reaction with H2SO4 NO2, which is an electrophile which acts on the benzene. You have to write the resonating structure, loss of proton, and you get your corresponding nitrogen. That is an example of electrophilic aromatic substitution. That is your anilide to para-bromo is example of electron donating group present activators. This is plain electrophilic aromatic substitution. This is plain electrophilic without any substituent in the ring. Remember this. So if they just write it as an example, give an example for electrophilic aromatic substitution that you have done. Example is nitrobenzene. Example is what? Nitrobenzene. Same thing you have done. Seventh experiment is what? What is seventh experiment? It's preparation of benzoic acid from alkyl benzoic. Preparation of benzoic acid Preparation of benzoic acid from alkyl benzoate. So what is alkyl benzoate? You take with R. Consider as methyl benzoate. You treat it with aqueous annealation. Heat it. It undergoes hydrolysis reaction. It undergoes what? It undergoes hydrolysis. So it's an example of what? If they try to, in the exam, they can give an example of hydrolysis reaction means in the Viva they will ask for the synopsis. What reaction will be there? Conversion of alkyl benzoate to your benzoic acid. What it is? Conversion of alkyl benzoate to benzoic acid. That's an example of hydrolysis. Just make a note of it. So conversion, example of hydrolysis reaction is conversion of alkyl benzoate to benzoic acid using sodium hydroxide. Using sodium hydroxide. So it can also be, it's an hydrolysis or it can also be known as a saponification reaction. It can be also known as saponification reaction. So what are the product is formed is sodium salt of benzoate, sodium benzoate, which are treated with HCl, you get your benzoic acid. So basically because sodium hydroxide it becomes sodium benzoate. So that when you treat it with HCl, you get neutralize it, you get your benzoic acid. Okay? Understood? This was the seventh reaction. Seventh reaction is nothing but hydrolysis. Example of alkaline hydrolysis or saponification. Alkaline hydrolysis is also known as what? Saponification. Remember this. Give an example of saponification reaction. So, alkaline hydrolysis reaction is also known as what? Saponification reaction. Alkaline hydrolysis is also known as what? Saponification reaction. Got it? So, we'll go for the next. You know the hydrolysis OH attacks. So, what happens? Your RC double bond O R. O minus attacks over here. This goes R. You get RC O minus OR OH. When this comes out, your ester groups goes out. Your ester groups go out, and you get your RC double bond O. This is how the hydrolysis reaction occurs. This is how the hydrolysis reaction occurs. Okay? So now let's go for the next reaction. Next, synthesis. What is the next thing? Preparation of 1-phenyl as a 2-naphthalene. Preparation of 1-phenyl as a 2-naphthalene. Okay? Preparation of 1-phenyl as a 2-naphthalene. How do you prepare? How do you prepare? You take aniline, you take aniline, you do its diazotization reaction. What you do? You take aniline and you do a diazotization reaction. You do a diazotization reaction. You do a diazotization reaction. So aniline gets converted to a diazonium salt. So what is the next step? The diazonium salt which is formed. You have to do it at 0 to 5 degrees. If you don't do it at 0 to 5 degrees Celsius, your diazonium salt will break up to give your C6H5 diazonium, which is not. So you should have N. So this will be done at 0 to 5 degrees. The temperature has to be maintained at 0 to 5 degrees Celsius. You get your diazonium salt using your NaNO2 and HCl at 0 degrees, vanillin gets converted into NH2, gets in presence of NaNO2 and HCl at 0 to 5 degrees Celsius. You get your diazonium. What is the next step? You treat your beta naphthalene. You take your beta naphthalene in sodium hydroxide. Okay? So what happens? It forms naphtha oxide ion. So this comes over here and this comes over here and you get a negative charge. So this negative charge gets your electrophile, that is diazonium charge, that will be attacked on the second position and you get one phenyl as the last step is loss of proton to get your aromatization and you get your one phenyl as a 2 naphtha. Why it is called one phenyl as a 2 naphtha? So this is naphtha 2. So what is attached? Phenyl and aza group is attached at your second position. So that's why it's called one phenyl. There is phenyl attachment. Aza 2 naphtha at the second position there is an attachment. That's why it is known as one phenyl aza 2 naphtha. What is the first reaction? Diazotization followed by your electrophilic substitution reaction on your beta naphtha at the second position. That is your example is diazotization followed by your azo coupling. It's an example of azo coupling reaction. So it's an example of what? Azo coupling reaction. It's an example of what? Azo coupling reaction. It's an example of what? Azo coupling reaction. Okay? Got it? So what's an example of azo coupling reaction? Preparation of one phenyl as a 2 naphtha. Preparation of one phenyl as a 2 example of azo coupling reaction. So if the examiner asks us things, you have to know. So next reaction is synthesis of benzene from benzoyl. Synthesis of benzene from benzoyl. So what is benzene? It is a diketo compound. Benzene is what? A diketo compound. It is prepared from benzoyl. Benzoyl is what? Alpha hydroxy ketone. So what is an example of conversion of alpha hydroxy ketone? That is your benzoyl. So what is benzoyl? So this is your benzoyl. Okay? This is an alpha hydroxy ketone. Why it is called alpha hydroxy? There is an hydroxy group which is at alpha position to your carbonyl ketone. That's why it's known as. This is when you oxidize with HNO3. This is an oxidizing HNO3 is an oxidizing agent. So it gets converted into what? C=1O. So this is an example of 1,2-diketo. Okay? So your alpha hydroxy ketone gets converted into a diketo compound. Okay? 1,2-diketo compound. That's example of your conversion of benzene to benzene. That's conversion of benzene to benzene is an example of oxidation reaction where your alpha hydroxy ketone gets converted into a diketo compound. What happens? Your alpha hydroxy ketone gets converted into a diketo compound. Okay? That's an example of oxidation. This is the second example of oxidation. If they are specific, then from conversion of benzene to benzene, then it is an oxidation. Even benzoyl chloride to benzoic acid is also an oxidation. What is the oxidizing agent used over here? What's the oxidizing agent used over here? Concentrated nitric acid, HNO3. Concentrated nitric acid is used as an oxidizing agent. Is used as an oxidizing agent. Got it? The next reaction is synthesis of dibenzyl acetone. Synthesis of dibenzyl acetone with the help of acetone, 1 mole of acetone and 2 2 mole of benzaldehyde. So when 2 moles of benzaldehyde reacts with 1 mole of acetone, you get an. So when 2 moles of benzaldehyde reacts with 1 mole of acetone in presence of dilute NaOH, okay, it undergoes a condensation reaction. So example, this is an example of condensation type of. This is an example of what? By 2 molecules come together. They condense together to form a 1 molecule. So it's an example of condensation reaction, and it is known as Claisen-Smith reaction. It is known as what? Please make a note. It's known as Claisen-Smith. So preparation of dibenzyl acetone from benzaldehyde and acetone is known as Claisen-Smith reaction. Very important to know. It's known as what? Claisen-Smith reaction. It's known as what? Claisen-Smith reaction. It's known as Claisen-Smith reaction. Got it? So what it is? It's same as, it's also known as crossed aldol condensation. It is also known as crossed aldol condensation. Why is it known as crossed aldol condensation? You got an aldehyde, benzaldehyde, which does not contain any alpha hydrogen. It reacts with a ketone. It reacts with a ketone in presence of a base. So what happens? The first step is generation of your nucleophile. So generation of a nucleophile. Generation of, put down your button. So what is it? Your acetone. So in presence of, if you know aldol and OH, so it will remove a proton from your alpha hydrogen atom to give you a nucleophile. Okay, this CH2 minus which is formed, that acts as a nucleophile that attacks on the carbonyl carbon of your benzaldehyde to form OH. So what happens when it attacks over here? CH double bond O H CH2 minus C double bond O CH2. So what happens over here? This attacks over here, this goes up and it gets propagated, you get CH OH CH2 C double bond O. Yes, this is followed by dehydration. You get a double bond. Okay. What's the next step? You got another alpha hydrogen atom. You got another alpha hydrogen of your acetone. So that will again react with NaOH to form a second nucleophile. CH double bond C double bond O CH2 minus CH2 minus CH2. And that CH2 minus will again attack on your carbonyl carbon of your benzaldehyde. Again, it undergoes nucleophilic attack on the carbonyl carbon of your benzaldehyde, and you get a double bond. That's why you get a dibenzal. Why benzal? Because there is a double bond. Alkene dibenzal acid. Double bond is benzal. That's why it is called dibenzal acetone, because two benzaldehyde groups attached to your acetone. That's why it is called dibenzal, and it's an example of what? Claisen-Smith reaction. It's an example of what? Claisen-Smith reaction, and it's also known as what? Crossed aldol condensation. It's also known as what? Crossed aldol condensation. Got it? Did you write? So it's an example. If they ask, give an example. What is an example of crossed aldol condensation that you have done in your lab? That means it's preparation of dibenzal acetone. It's a dibenzal acetone. Preparation of dibenzal acetone. Okay. What's the next thing now? Cinnamic acid. Cinnamic acid. So what is this cinnamic acid? When you treat benzaldehyde with an base like sodium acetate, sodium salt of acetic acid. In presence of acetic anhydride. In presence of what? In presence of what? Acetic anhydride. You take benzaldehyde. This is a very important reaction that you have to do. No. When you take benzaldehyde, you treat it with acetic anhydride in presence of sodium acetate. Recite the condition. Benzaldehyde, acetic anhydride in presence of sodium acetate. It undergoes a condensation reaction to give you an alpha beta unsaturated aromatic acid. What do you get? An alpha beta unsaturated aromatic acid, that is phenolic acid, and that's known as Perkins reaction. Reaction is known as what? Perkins condensation reaction. Now listen carefully to the mechanism. You have got your records in front of you. Please refer your record. Okay? Please see your record. Okay? Look at your record. So what is the first step? You got sodium acetate. Yes. You treat it with acetic anhydride. Yes. So what is this acetic anhydride? Sodium acetate. It is a base. It will abstract the proton from your acetic anhydride to form a nucleophile. It will generate a nucleophile. And CH2 minus CH4 CH3. Yeah, you get this nucleophile. You get this nucleophile. Write it along with me. You get your nucleophile. Okay? You get your nucleophile. First step understood? Yes, everybody understood the first step? Yes? Now I go to the second step. Along with this, you get your acetic acid. Okay? You get your acid. Now, the first step is what? First step is generation of your nucleophile. The first step is what? Generation of a nucleophile of acetic anhydride. Okay, that's the first step. Generation of a nucleophile of acetic anhydride. That is the first step. Now, once your nucleophile is generated, yes, the nucleophile is generated. Yes. So here you are having benzaldehyde. Okay. You got a benzaldehyde. Now you got a nucleophile. CH2 C double bond O O C double bond O. So what is the next step? This nucleophile that is attacks on your carbonyl carbon and you get this. Okay? You get your, and in water you get your corresponding O minus H CH2 C double bond O O. Here. Did you get this? Did you get this? Right? Right? Did you get this point? Did you get this step? Okay? This is the. Now what happens next step? This O minus that is formed over here. Okay? The O minus that is formed, it will attack on this carbonyl carbon. And this comes up. Okay? What it is in the arrows? This O minus attacks on this carbonyl carbon of your acetic anhydride. Okay? Please write it down. Okay? Simultaneously so that you can. So what happens the next? H O O minus 3 C2 C double bond O. The cyclic intermediate is called. Can you see the cyclic intermediate? Yes? under cyclic intermediate. Understood? Got it? So write it down along with me. Everybody, those are listening also. Please write it down along with me. Now you have got a negative charge over here. Can you see this negative charge? Okay? Now this comes over here, and this comes over here, this comes here, and this comes up over here. See, this negative charge comes here, the O that is linking between the two acetates forms a double bond, and this carbonate becomes O minus. So you get an acetate ion. You get an acetate ion with a reverse position. With a reverse position. Got it? You understand everybody? So let me see. Right. So you get CH. So what do you get? O. O. C double bond O. C3. Yes. And the upper portion, what is? Yes or no? So you get, and this breaks away, and this carbon, another, you get CH2, C double bond O minus. Got this step? Did you get this step? What happens? See over here. This comes here, this forms double bond, and this one. So there is a breakage over here. Okay? There is a breakage over here. This bond is broken. This bond between these two carbons and oxygen is broken to form a carbon, and this forms O minus that you get over here. This C double bond O is this one. Okay? This is how you get this C double bond O minus. Got it? Yes or no? So you get your acetate ion. Okay? You get your acetate ion. You got your acetate ion. Did you get it here, everybody? So what happens next step? I'll just rewrite it, making the intermediate. So you get, and let's write it again. C H O O C 1 2 3 O minus. Okay? You get your O minus. Now what happens next? So this is an charge. So this will attack on your another molecule of acetic ion. This will attack on another molecule of acetic ion. So this attacks over here. This goes off. Okay? This attacks over here. Form an ester over here, and you get back your acetate ion O minus, and you get CH, CO, CH3, you get your CH2, C double bond O minus, C double bond CH2. Okay, this is what you get. You get an ester again over here. Okay, acetate gets converted to an ester, and again you are getting an acetate. So acetate is what? A base. Acetate is a base. This base abstracts the proton from this active. This is between two electron metals. So this is known as active methylation group. So this acetate that is formed will abstract a proton from here. So once it abstracts a proton from here, this bond will break and double bond, and you get again back your, you get again your CH double bond CH, C double bond O CH O, C double bond O CH3. Right now, this again the acetate is removed from here. See, the acetate from here is removed. It's a good living group. It is left. Acetate. So this again acetate will break over this ester bond. It's a base. So it will undergo base catalyzed hydrolysis to give your corresponding acid. Your ester gets converted to an acid. This is the exact mechanism of Perkin's reaction. You might have learned something else last year. If I am not mistaken, directly base abstracts the proton from somewhere, base will come over, it will be the proton proton acetate goes up, it gives the base hydrolysis. Where that base comes from your acetate which is present in your molecule, and you get your corresponding alpha beta unsaturated aromatic acid. So this is known example of Perkins reaction. This is an example of what? Perkins reaction. This is an example of conversion of benzaldehyde to cinnamic acid. This is an example of Perkins reaction. It's an example of Perkins reaction. Okay? Got it? Now, this next is synthesis of para-hydrobenzoic ethanol from PAPA, that is para-amino. It is also an example of what? Conversion of your amine to diazonium salt, then displacement of your diazonium salt with your iodine, Ki. So when you heat it with Ki, your iodine displaces or substitutes your diazonium salt with your iodine. So it's an example of a substitution reaction. It's an example of displacement or substitution reaction where your diazonium salt it gets converted to your iodine, where your iodine replaces your diazonium salt. So first step is diazotization followed by your displacement reaction. Displacement reaction. That's an example of preparation of para-hydrobenzoic acid. Para-hydrobenzoic acid. Uses of diazonium salts have to be studied. What all things? What is Siemens reaction? What is Sandmeyer's reaction? Everything. How will you prepare benzene from aromatic acid? How will you from the diazonium? All these things you should know. Okay? Everything is there in your record. You have to read this entirely. What are the uses of orthophosphoric acid? You get your benzene. You heat it with water. You get your phenols. You treat it with copper cyanide. You get Cl. Copper chloride, you get Cl. Fluoroboric acid, you get your fluoro derivative. This is how you have to remember the different applications of diazonium salt. This is important from your examination point of view. Next is acid value. What is acid value? How many times? Can you remember? It's number of milligram of pH. It's number of milligram of pH required to neutralize free fatty acid present in 1 gram of fat oil. So what it is? Acid value is nothing but number of milligram of pH required to neutralize, underline, free fatty acid. The word free fatty acid is very much important. Okay? It's very much important. Okay? 1 gram of, it is used to determine the rancidity of your oils or fats. So that is edibility of your oils and fats. Its value should be less than 1%. There are two types of rancidity, oxidative and hydrolytic rancidity. Oxidative rancidity leads to your formation of your corresponding aldehydes and ketones and smaller acid, whereas hydrolytic rancidity leads to your hydrolysis of your ester bonds to give your alcohol and your acids, long chain acids. So these are the two products. This foul smell. Rancid is nothing but the foul smell that you get from your oils and fats on exposure to your moisture or air. That is known as rancidity. All these things are important. Next is saponification. What is saponification? What is saponification? Saponification is nothing but number of milligrams of pH required to neutralize free acid, fatty acid present, and doing complete hydrolysis of your 1 gram of fatty. It is number of milligrams to neutralize free fatty acid present and doing complete hydrolysis or complete saponification of 1 gram of fat and oil. Very important. Very, very important. Okay? Very, very important. Okay? So what do you come to know by saponification value? You come to know the chain length of your fatty acid which is present in your fats and oil. You come to know the chain length. So it helps in determination of your molecular weight of your fats and fatty acids. So it helps in determination of your molecular weight, and your saponification value is inversely proportional to your molecular weight. So if the saponification is high, your molecular value will be low. It's a low chain containing fatty acids. So this is how what data you come to know by your saponification value. This is what you come to know by the saponification value. Okay. What the next? Last one is iodine value. What is iodine value? Number of grams. Till now it was milligrams of kg. This is number of grams of iodine. Number of grams of iodine which is absorbed by 100 grams of fat oil. Which is absorbed by 100 grams of fat or oil. Okay? So what happens? The method is either your what methods can be used? What are the three methods that are used for this? We use iodine monochloride or iodine monochromide. You use for the its Hubble's method or pyridine hydro or fixed method. Okay, these are the three methods for determination of your iodine value. Iodine monochloride can be used. So what happens is iodine monochloride gets added across the double bond. And the excess of iodine monochloride, you always take excess of iodine monochloride, then will react with your Ki to liberate iodine, and the liberated iodine is then titrated against your sodium thiosulfate. Titrated against your sodium thiosulfate. You should know what is your primary standard over here. For in case of your sodium thiosulfate, potassium chromate is your primary standard. Why you use primary standards? To know the exact normality of your sodium thiosulfate. So what is the application of your iodine value? It is used to determine the degree of unsaturation. What is it used? It is used to measure the degree of unsaturation. It is used to measure the degree of unsaturation. So higher the iodine value, more will be the number of unsaturated. It is used to determine whether it is a drying oil, non-drying oil or a semi-drying oil. Non-drying oil, the iodine value should be less than 150. Semi-drying oil between 150 and 130 iodine value. And drying oil which contains higher number of unsaturation, polyunsaturation, linoleic acid, they have the iodine value around more than 130. This is how you can come to know the if it is a real acid, it is used to determine the iodine as well as whether it is prone for your oxidative degradation. We come to know by this iodine value. Okay, these are the important topics from your practical examination point of